So if you have a router over here and you configure proper routing on the router, and the router has multiple interfaces, it is going to build a routing table, like a map of the network, and forward packets. You guys agree? No control. All traffic is allowed to go through the router by default, which is a good thing. I'm connecting. So router connects. It provides a connectivity. I am recording right now. I'll be giving it to Vikas. You can download it from Vikas. At the end of the class, I'll upload it to Vikas. Is that okay, Manpreet?
Yes, sir.
So just remind me at the start of the classes to start recording, because sometimes I might forget. So if you don't mind, just let me know. Right now I'm recording. You should see this sign over here. See this small little sign over here it's got that red button blinking? That means I'm recording. So router connects. If the router connects, what is the job of a firewall? So this is my outside network. External networks coming in. My job of my router was to connect up to these outside networks. Once a connection is made, I have my internal network over here. Do you want traffic to come in unchecked from the internet towards your internal network, which is your internal resources? Your corporate servers, your web servers. All right? So that's your first line of defense, is your firewall. What is a firewall? Essentially, it is nothing more than a router, but the hardware is optimized for security. So the default action, like a router connects, firewall blocks and only allows traffic that should be allowed to come in from the outside into your internal network. Everybody okay with that? You understand what the function of the firewall is? So the firewall blocks traffic coming into your network from the outside. So you put all your policies, all your rules on the firewall to specify what traffic should be allowed to come in from the outside towards your internal resources. Everybody okay with that? You understand the concept? Yeah?
Yes, sir.
Yep. Just on the chat, if you guys don't mind, put a yes so I know you guys are following along. That also makes sure that you don't go to sleep on me. All right, so you guys understand what the firewall is. Can we do it on a router by applying an ACL? Limited, yes, you can control some elements of access. But let me just give you an example of where it limits you. Let's say I don't want people coming in from outside to inside. I don't want anybody coming in from the outside. How would I do it on a router, Gopalan? What type of ACL would I write over here? ACL that says deny IP any. Agreed? Because I don't want people coming in from outside to inside. Now the problem with that ACL is when my traffic goes out from inside to outside and it tries to come back in, isn't it going to be denied by your ACL? Because that's also coming from outside to inside. Yeah, it's return traffic, but the router does not know it's The ACL does not know it's return traffic. It says deny IP any. So not only did this block my traffic coming from what? Outside to inside, but it also blocked my request that went out. That it went out no problem because I didn't block it from in to out. But when it came back, return packet. So I sent a request to a website. The website is responding back. The response will be blocked based on this ACL. So I need to do a mechanism called inspection, which is a firewall functionality. What inspection does is whatever traffic is allowed to go out, it creates or inspects the traffic and creates return entries. That's what a firewall does. It's not just about denying all traffic from out to in, but it should also allow traffic, return traffic to come in. That's done by a functionality of the firewall called the inspection policy. Everybody okay with that? You guys understand that? Gopalan, does that answer your question? Now, at the same time, you might say, well, can I do that inspection on my router? Yes, you can. On the router, you have the ability, not using ACLs, but on the router, you have the ability to use a feature on the routers called zone-based firewalls. What is a zone-based firewall? A zone-based firewall is basically a firewall feature set installed on a router. We'll give you similar functionalities as a firewall, but on a router. Not the ACL, as you said, Gopalan, but using a zone-based firewall. Having said that, the issue that I have with that is the router hardware is not optimized for security. Sorry, this was supposed to be the firewall. The firewall hardware is optimized for security. The router is optimized for what? Router hardware is optimized for what? For routing. Do you get my point? So yes, you can do the firewall functionality on a router, but it's not recommended because the hardware is not meant for it. So you're really doing it in software. Let's say you're moving your house. You're moving from one apartment to the other apartment. Can you use your normal car to transport your, maybe your TV, maybe your luggage from one house to the other, from the one apartment to the other? Yes, you can use your normal car to do that. But you might cut your seats. You might put too much load on that car. Whereas if you get or rent a truck to do the same thing, you're better off. Do you understand what I'm saying? So the analogy that I'm trying to give you over here is the truck is what the firewall does. It basically is meant for doing one thing and one thing only, that is security. It's optimized for it. It's meant for it. You can do that same functionality on a sedan like a car, but by putting stuff inside the car, but you might damage the car. It's not really meant for it. Same thing over here. A router is meant for routing. Let it route. Do the security functionality on a firewall. Everybody okay with that? You guys understand that?
Yes, sir.
So we're going to be taking a look at the different type of firewalls that Cisco puts out. We'll take a look at a firewall on a Cisco box called the ASA. Now, a little bit about the ASA family. ASA is the firewall that originated from Cisco. So it's the firewall from Cisco. So the product is called ASA. The current version of the ASA firewall is 9.x. That's the operating system version. All right, we're going to be taking a look at how the ASA Firewall 9.x works. This is your firewall. Everybody okay with that? Clear on that? So in most of the network, you find router upstream to the ISP, then followed by the firewall. Why so? As I said, router for routing, firewall for blocking. So the router, in terms of routing, it is the best device for doing the routing, to learn the routes, to forward the packets towards the ISP. So that's why you would have the router connecting up. The router has better functionality for routing. But once the traffic gets is passed through the router because it's done its routing, now I need to make sure that traffic is traffic that is allowed within your network. So you put the firewall behind it to secure it. In the older days, some of the...
Sir, I have one question. Sir, one question I have. Sir, in the some environment, we can see that they are using the firewall for connecting the ISP. Is that okay? Like the Sonic firewall,
yeah,
like Sonic firewall doing.
Yes, I wouldn't compare Sonic firewalls like a low-end firewall. Then you have Linksys firewalls. If you have to compare firewalls, you want to compare firewalls like you want to compare your ASA to a firewall like Checkpoint, or towards to a firewall like Palo Alto, Fortinet, Barracuda. These are more brands that you need to compare. But at the same time, is it okay to put a firewall as a first device? Nowadays, it's okay, because nowadays the firewalls have good routing functionality. In the earlier stage, the firewalls were just basically firewalls, so it didn't have good routing capabilities. So it's both ways. It can work both ways. It depends on what is your prime focus. If your prime focus is security and you want to make sure no traffic that's not supposed to be in your network comes in, firewall, putting it as the first device, is the best way to do it. But if that's not your focus, you want to have some traffic come in and then segregate the traffic based on the firewall, then you put the firewall behind the router. It all depends on your scenario. We'll take a look at that as we go through it.
Sir, so ASA new generation ASA can also we can put directly connect to the ISP. Am I right?
That is correct. Even the older ones you could.
Okay, thank you, sir.
Even the older ones you could. So we'll take a look at extensively how a firewall works. All right. We'll bring it up from scratch. So the things that we'll be taking a look at in terms of the firewall, I'll write it down over here. So we'll take a look at ASA 9.x. We'll take a look at basic configuration. We'll take a look at routing on the firewall. We'll take a look at traffic flow through the firewall. We'll take a look at NAT on the firewall. Under NAT, we'll do dynamic and PAT. I'll tell you the difference between NAT and PAT when we get to it. We'll also do static NAT and PAT. Here my objective is to give you an overview. We'll get into the details about what the difference between the two is as we go through it. So in terms of the 9.x firewall, we'll bring it up from scratch and I'll show you how to configure it. Basic configuration, routing, traffic flow through the firewall, as well as NAT on the firewall. Everybody okay with that? Another thing that I'll also do over here is provide high availability. What is high availability? High availability is redundancy. So if you have a single firewall and that firewall goes down, generally the firewall sits between your inside network and your outside network. If you have a single firewall and the firewall takes a dump, guess what? All traffic going from inside to outside is blocked. You guys agree? So you don't want to have a single point of failure. This is called a single point of failure. Avoid it as much as you can. And that's what is done by providing high availability and redundancy. How do I do it? I put two firewalls. So firewall 1 and firewall 2. Connect both of them to the outside switch, which connects to the outside router, and connect both of them to what? Inside switch, and connect up to the internal network. Now you can also provide redundancy at the switch level, the router level, and all that. My focus over here in this particular class is providing redundancy at what? At the firewall level. So we'll take a look at how to do high availability with it. The technique that the ASA calls it is called failover. So I'll show you how to configure failover between two firewalls. So one goes down, the other one kicks in. Everybody okay with that? So that gives you a foundation of what the ASA firewall is. Good so far?
Yes, sir. Sir, I have a question.
Go ahead.
Yeah. Actually, for here we also see about the clustering part.
You see what?
Clustering.
You see what?
Clustering.
Clustering, yeah. Clustering is available over here. That's why I drew the thing as the box. That is clustering. In 9.x, the one difference between the 8.x and 9.x is the capability of doing clustering.
Okay.
All right, if you've done 8.x, clustering was not available. 9.x, they did include clustering capabilities.
Okay. Yes.
All right, so that is
Yes,
the part of it. Now, the next thing we'll take a look at over here is your IPS device, which is called Intrusion Prevention Systems. What are intrusion prevention systems? You need to understand that. Let's say I had a network where I had an edge router connecting to the internet. The router connects up into your firewall. Firewall connects into your servers. Let's define the capability of the firewall. What does the firewall do? The functionality of the firewall is when a packet comes in, a network packet comes in, it checks whether the source IP is allowed to communicate to the destination IP. Destination IP would be server 1, server 2, or server 3's IP, and each server would be running a specific service. So for example, this is your web server. So it's going to be running the port 80 and the HTTPS port. As an example, let's say server 2 is your DNS server. So it's going to be running port 53. Let's say server 3 is your TFTP server. So it is going to be running a service 69. Let's say this is .3, .2, and this is .1. So on your firewall, what you're going to do is you're going to specify, hey, listen, I want any device on the outside coming in to where? To a destination of, let's say this network over here is 192.1.100.x, So I do want to allow access from anyone to a destination IP of 192.1.100.1 as long as the destination port is what? Either 80 or 443. I don't want anybody coming in to 100.1 for, let's say, DNS or other services. I only want it to come in for a specific port number, certain application. Similarly, I'll have another rule that says anybody on the internet can come into 192.1.100.2. .2 is this guy for what? DNS. Agreed? And the third rule would be I want to allow anybody coming in for 192.1.100.3 for what port? 69. So if they try to mix and match, it's not going to work. So yes, I'm allowing access to port 80 and 443 my web applications, but only if the destination IP is 100.1. I'm not allowing it if somebody tries to do HTTP to my DNS server. Everybody okay with that? Clear? Now, that's fine. What if somebody does try to go in onto server 1 for web? I'm sending a packet with the source IP of, let's say, 1.1.1.1. Destination IP is 192.1.100.1, and the port number is port 80. Is the firewall going to allow that packet coming in? Remember, I did allow it. Any source to 100.1 for port 80. Agreed? Did I check whether this packet was part of an attack? Did I check the data portion of the packet to see if that header might contain a characteristic that is in line with an attack that has happened on the internet in the past? There's thousands of network attacks that have happened. What Cisco has done, and other vendors, they have created a database. In this database is all the patterns, the packet patterns for well-known attacks. All right? That database is on a device called the Intrusion Prevention Systems. The job of the IPS is not to check who is allowed to communicate to whom, is to check when the packet comes in, whether that packet that is allowed is a good packet or is it a well-known attack packet. It's very similar to your antivirus. What does the antivirus do? It checks a file for the content to be corrupted by a signature, the signature of a particular attack or a virus on that file. Anytime a virus hits a file, it does certain type of damage. The antivirus companies go in and find out what that damage is and take a snapshot of it. Now, when a file comes into your PC and the PC detects that using the antivirus database that the file contains the same characteristic of an attack, it will quarantine the file or clean the file. Similarly, IPS does the same thing, but it does it for what? It doesn't do it for files, it does it for network traffic or network packets, looking at packet headers and contents of packets. It doesn't check files on your PC. It's checking for what? Traffic on the link. So even though you have a firewall, you're not completely protected, because on the firewall, you're basically saying allow the packet to come in to this IP address for this port number, but it doesn't check the content, whether the content is malicious or not. Is it something that is causing network problems to that particular device, which is well documented, and that documentation is inside a database, which is on a IPS box. So what is the functionality of an IPS box? The functionality of an IPS box is to do what? Allows you to check the packet for well-known network attacks. Because well-known network attacks basically are what? They have a pattern, and inside the database is that pattern of the packet. It also creates a baseline for your network. What's a baseline? Normal traffic that is going through your network. IPS can also detect anomalies. Anomalies are what? How should I put it? Uncharacteristic behavior. Uncharacteristic behavior in your network based on the baseline that is created. So what it does is it takes a look at what is normal on your network, and if it sees that something that is abnormal coming into your network, it notifies you. It doesn't necessarily block it. It'll tell the administrator, hey, listen, you know what? I've never seen this type of traffic coming in the past. Is this something that you want to allow or not allow? All right. So we'll take a look at what an IPS is, how to configure it. So far, so good. It checks for what? Checks for network traffic that might be bad or might be an attack against the network. You guys understand the difference between a firewall and a IPS device? Both are equally important in today's networks. So not just by blocking a packet coming into a particular server for a particular port, you're now checking the actual content of the packet and matching that content against a well-known attack. If it matches, you can take an action of dropping the packet. Everybody okay with this? You guys understand this? We'll take a look at that. We'll again do a basic configuration, bringing the IPS up, tuning existing signatures. What do I mean by tuning existing signatures? Signature is basically that pattern. Tuning it, maybe when Cisco gives you that IPS, it has a set of built-in signatures with like a default characteristic. I want this attack to alert. Maybe you want that particular attack to block. I want the IPS to block that traffic rather than just letting the administrator know. So you can tune existing signatures and their actions that you're taking with it. Or for that matter, you can also create custom signatures. What are custom signatures? Signatures that you recently found out there's an attack that has happened, and that attack has this particular characteristic. You have the ability to go in and check that characteristic, and based on that, do a block. All right. So we'll also take a look at how to create custom signatures where? On my IPS device. Now, IPS, just to let you guys know, Cisco bought another company that was like a Gartner leader in terms of IPS. The name of that company was called SourceFire. All right. So they took that SourceFire product, repackaged it, and that product now is called the Firepower product.